Welcome. In this section, we will work on another project. The project is to create a smart contract for voting. Contract owner should only able to register candidates. Once the candidates are registered, anyone can vote for the registered candidates. Contract should make sure that vote has been received for registered candidates only. And lastly, anyone can check anytime who is leading. And finally, anyone should be able to see the result when voting is completed. That means our contract should be able to identify the contract owner, and contract owner should only be able to register the candidates. Voters should be able to vote and also should be able to inquire about the voting counts for any valid candidates while voting is in progress. And finally, anyone should be able to get the details of the winner when voting is completed. We will also need to implement validation logic to verify the candidates and also handle the errors, like if someone tries to call result function to get the winner detail when voting is still in progress. The caller should get error message because the result can be declared once the voting is completed. Now I would recommend you spend some time and try to design the solution for this smart contract. That's all in this lecture. In next lecture, we will talk about the possible design of the solution for developing this voting smart contract. Thank you, and we'll see you in next lecture. Welcome. I'm sure you must have some idea now how you can design your smart contract. Let's see one of the possible design. First of all, define state variable of address data type to store contract owner address. Define dynamic array of address data type to store the addresses of registered candidates. Then define a mapping table with candidate address as key and number of received votes as value. Then we will need one constructor to store the owner's address, one modifier which will have require owner only to execute some particular function like registration of the candidates. Then we can have functions like a function to register the candidate, and that is to push candidates addresses to dynamic array. Another function to validate the candidates. When a voter calls a function to vote, the voter will enter the address of his favorite candidate. Now that address should be registered candidate. So we will need to look up into the dynamic array to ensure that the address passed by the caller or voter during voting is present in this dynamic array. Another function can be called by anyone to vote. Caller will provide address and the vote will be recorded in the mapping table. Another function can be called by anyone to check the vote counts while the voting is in progress. Here the caller will pass the candidate address as a parameter, and function will look up in the mapping to find the mapping key value entry. This function will return number of votes only if voting is in progress. Finally, one function to declare the winner. Anyone should be able to call this function and get the candidate details who received maximum vote. So here we will need a logic to loop into mapping and find the record with maximum number of votes. This function should only return if voting has completed. There should be one more function which will be only executed by owner to set the status of voting, like if voting has started or not, or voting is completed. So here we will use enums. So it will help you actually when voters will try to count the vote. This function should be executed only if the voting is in progress. So you can check the status and then only return the voting count if the status is in progress. Similarly, in this function you can check if status is completed, only the winner can be declared. So voting is one of the best use cases of decentralized application, and you will practice many features of Solidity like address, array, mapping, functions, error handling, and also enum. So spend some time and think about how you can write this smart contract. So that's all in this lecture. In next lecture, we will develop it. Thank you, and I'll see you in next lecture. Create one Solidity file and we can name it as voting.sol. First line would be Pragma Solidity compiler version. Define contract with the name voting. As we discussed in design, we need one address data type to store the address of contract owner. So define data type address public and we can name it contract owner. We also need to store election candidates detail, and there may be more than one candidate, and this time we don't know how many, so we need a dynamic array of address data type to store the candidate addresses. We can define address dynamic array as public, and we can name it as candidate list. So address dynamic array public, and we can give the name candidate list. We also need to store the votes received by all these candidates, and here we can use mapping. And in the mapping, we will have address as the key and number of votes as value. Address and number of votes will be unsigned integer. So let's write unsigned 8. So here you can define unsigned 8, 16, whatever you want. Then public, and we will have to give the name of this mapping. So let's give name as votes received. We need couple of more variables like to store winner's address and the number of votes received by the winner. So let's define one address and unsigned integer. So you don't need these variables defined as state variables. I just defined to show the results in Remix browser. So we will get the getters and we will see the values inside winner and winner votes. Otherwise, we can very well use local variables inside the function. We will write a constructor to store the contract owner address at the time of deployment. So let's define the constructor. So here contract owner equal to message.sender. Whoever will deploy this contract, the address of that account will come in msg.sender, and that will be stored in contract owner. So in this contract, there will be at least one function which should be only executed by contract owner, like the registration of the candidates. So we can first define a function modifier, and we can use this function modifier to restrict the execution of particular function by only contract owner. So let's define the modifier. Inside the modifier, we can check if the message.sender is equal to contract owner or not. If true, then it will execute the function. So now we have a basic framework for our voting contract, like we have defined state variables, we have created constructor, and we have created modifier. In next lecture, we will start creating the functions. So we need a function to register the candidate who will be standing in this election, and the registration function should be executed only by contract owner. So we can write function and we can name it as register candidates. We will pass the address of the candidate who will fight the election, and then add the function modifier so that only owner can execute this function, and then public and open the brace. Remember, we have an address array to store the candidate's address. So we will just use push member of the array to add candidate address in that array. We can write candidate list dot push, and we can pass this parameter. So write candidates list dot push, and in bracket we will write underscore candidate, the address which we are passing through this register candidate. So when owner will call this function and pass the address, that address will be added to this candidate list, and that candidate will be considered as the registered candidate. So let's deploy it and see if we are able to register candidates or not. Click on deploy, expand this, and you can see we have a setter function called register candidates. This is setter because when we will add the candidate, it will be saved in our blockchain. Then we have getter. And now we have an owner who has deployed this contract. The address starts from CA3. So if you click on the contract owner, you will see the contract address. So only this contract address can register the candidate. So let's copy the another address and add in the candidate list. So this second, if you copy the second address, the second address will be like our candidate number 1 will be our first candidate. So let's copy this address. Now change to again owner, because owner can only register the candidate. We will take this address, whatever we have copied here, we will paste it here. Now click on the registered candidate. You can see this transaction is successful, and if you now enter 0 here in the candidate list array and click on this candidate list, it will show you the first candidate. Now let's copy the second candidate, and we can copy this third address, and this will be our second candidate. Copy the address, change to owner, and again paste it here against registered candidate candidates function. Click on register candidate. Again, this is successful. Now if you enter 0, you will see your first candidate. If you enter 1, you will see your second candidate. And if anyone else try to add a candidate, it should fail. Suppose I copy this fourth address and this is a third candidate. But if somebody else try to call this function, suppose this fifth, which is not an honor, and it tries to add that address which we copied and it calls registered candidates, this is successful. This will show you successful because the modifier will call this and check if it is only honor or not. So this is successful. This check is successful, but it will execute these lines only if this condition is true. So to verify, if you enter 0, you will see first. If you enter 1, you will see the second. If you enter 2, there is nothing. So the third candidate which this address tried to add was unsuccessful. Now we need a function for voting, and that function can be called by anyone to vote their favorite candidate. So in next lecture we are going to create another function called vote, and anyone can call that function and vote for favorite candidate. We need a function for voting. And as we discussed, anyone can call this function and pass the favorite candidate address to vote. So we can write the function vote and we can pass the address, make it public. So this function will be called by anyone and the caller will pass the address of the favorite candidate and the votes will be stored in our mapping. So key will be our address, which is this one, and value will be the number of votes. So how we can write? We can write mapping name and then provide key, which is candidate here, this address which we are passing here, equal to again mapping name and pass the address plus 1. This vote received candidate actually pointing to the number of votes here defined as unsigned integer in the mapping. So suppose person A calls to vote a candidate 1. He will pass candidate 1, and when we will increment 1, so the value of candidate 1 in this mapping will be incremented by 1. If somebody else, person B, calls candidate 1 again, then again the number of votes will be incremented by 1. You can actually write this statement in another simpler way, right? You can write votes received candidates plus equal to 1. This is the same thing. So whatever you like, you can write here. So I will just comment 1. So our vote function is ready. Let's deploy it. Now if you click on the contract owner, we can see that our first address is the contract owner. Now we have to add few candidates. So what we can do is we can just copy the second address, make it as a contract again, and then paste the address what we copied here in register candidates and click on this register candidate. So the transaction is successful, and if we click on this candidate list by entering 0, we should see the first candidate. Now copy the third address, it will be our second candidate. Again change to contract owner because contract owner only can register. Paste the address here, new address with the registered candidates. Click on register candidates. Now if you change it to 1 against candidate list, it will show you the second candidate. We can take one more. So copy the fourth address, change to contract address, paste the copied address with register candidates, click on register candidates. Now you have the third candidate at index 2. So if you copy any of the candidate address and paste it with votes received, you will see right now it's 0 because nobody has voted. So what we can do, we can take the address of candidate. Let's see 0x58 is the candidate, one of the candidate, it's a third candidate. We have this address copied and we can just paste it here with the vote. Click on this vote, and if you click now here vote received, it will give you count 1. If you again click on vote with the same address 2, 3, 4 times, and then if you click on this vote received, it will show you the number of votes. You can do it with some other address as well. So let's copy the second candidate's address from here and paste it at vote. Click on vote 1 time, 2 time, whatever you want. Now if you paste that address here with the vote received, it will show the votes as 2 for the second candidate. So we saw it is running fine, but there is a problem with design. Currently, anyone can call the vote function by passing any invalid address, and our mapping table will store the invalid address. So we should validate the address before we accept the vote. We already have candidate list array where we have stored all valid candidates. So we can look up the address in the array to check the validity before we accept the vote. We can write a function to validate the address. So let's see how we can do it. So in this lecture, we are going to write a validation function which will validate the candidate before it applies the vote. So we will write function and we will give the name like as validate candidate. So we want to validate candidate. So candidate is address type data type. We can make it view public returns bool. It will return bool true false. If it finds a candidate in the registered candidate list, it will return true. That means it's a valid candidate. If it doesn't find the candidate in the candidate array, then it will return false. That means that candidate is not registered candidate. That candidate is invalid candidate. Inside the function, we will write a for loop and navigate through each index of candidate list. That is our array. So we will run a for loop and one by one we will check if the passed address, which is passed as a parameter, is present in this candidate list or not. So we can write for loop for, we will start with I equal to 0, that is 0 is the first index of the array, and it will be less than, and the maximum value of I should be less than candidate dot length, because the index starts from 0. If you have 7 candidates, index will start from 0 and it will end at 6. So you need to run this I until candidates list dot length minus 1. So you can just write here I less than candidate list dot length, and then we have a third argument, that is your I plus plus, that is your increment. Then inside this for loop we can check if candidate list I, that means we are passing the index equal to the candidate, then return true. And after this for loop, suppose it doesn't find the match, we can return false. So by default the flag is always false, but you can write a return statement here as well. So we have the error here, it's like a comma, so it should be semicolon and function. So in this function we are passing an address. That address will be checked one by one in the candidate list array. If that candidate is present in that array, that means that is a registered candidate and it will return you true. And if after all this loop, if it doesn't find that candidate, the control will come here out of this for loop and then we can return false. Now what we can do here is, since our validation function is ready, we can call this validate candidate from vote function before we add the votes. So how we can add is, we have discussed in our error handling lecture about required, assert. Then here we can use a require and we can actually directly call this validate candidate function, and validate candidate expect one parameter as address. So we can pass this address candidate. What is doing here is, require is checking if validate candidate function is returning true, only then go ahead. Otherwise you can have some message like not a valid candidate. So when this function will be called by a voter, first require statement will call this validate candidate and the address passed by the voter will be checked in candidate list. If that candidate is registered in candidate list, then only it will go to the second statement where we are incrementing the votes. Otherwise it will give the error not a valid candidate. So let's deploy it and we can see how it works. So let's select the first one as our contract owner. Let's click on deploy. So our contract owner is address starts from CS35B. So we can add couple of candidates, copy the second address, change it to owner, and here in register candidates just paste it here, click on register candidate. So we have register first candidate at 0 index. Now we can select the third account, it will be our second candidate. You have to change this owner, click on register candidate. So we have first candidate at 0 index, second candidate at 1 index. So we have only 2 candidates now. So we have added validate candidate. Okay, so suppose somebody wants to vote this second candidate. So voter can enter the address and vote. So if we go and check the vote against this candidate, we can see, sorry, this is validate candidate. So if we go here and in vote received, if we paste it here, it will show you it received 1. But we have to test this function validate candidate. So how it will work? So suppose I'm a voter, I just take any address, okay, and I go here and just vote for that candidate. This candidate is not registered in our candidate list. I just copied this last address. If I click on vote, I will get this address, not a valid candidate. So that means our validate candidate function is perfectly working. So we need a function to inquire the votes received by any particular candidate. So when voting is in progress, if I want to know how many votes have been received by a particular candidate, I can just call this function. I will pass the address of the candidate and it should return the how many votes he has received. And it is pretty simple. As we have the mapping, we can just look up using the address of the candidate as the key and it will return us the number of votes as the value. So mapping is defined as public, so you can also get the getter and see the vote counts. But we also need to apply some error handling conditions. So technically you should not define mapping as a public here. Here I have defined just to show you how mapping will look like. So let's create the function for vote counts. We can name it as vote count and we will have to pass the address as parameter. We can make it public and it will return the number of votes, that is unsigned integer. And we can just return the mapping value by giving the key as candidate. So when the address is passed here, that address is the key for this mapping, and if you will write return mapping name and the address, which is the key, it will return you the value. So that's how mapping works. You just need to pass the key and it will return you the value. But again, we can also add here the same thing, the required validate candidate function, because anybody can call this vote count function with invalid address and try to find out what is the number of vote, right? So you can just write here, copy paste the same thing, required validate candidate, not a validate candidate, if that candidate is not present in the candidate list. So let's deploy it and register few candidates. So we will copy the second address, now change it to owner and paste it here with registered candidates. Click on registered candidates. Now copy the third address, change it to owner, paste it here. So now at least we have two candidates at 0 index and first index. Now suppose somebody is voting this second candidate, so voter will just pass this address, click on the function, it will call the function. So we can just click multiple times, you'll see like multiple votes will come here. Now the other candidate is at 0. So let's copy this and again on the vote function just paste it here and give some votes. Now we have this vote count function. So we can call this vote count. Let's pass any address. Let's see how many votes this address has received. So it's giving you 1. What is the second candidate address? Let's see the second one. So the second candidate has 7 votes and this is coming from the mapping. So key is your address and value is your votes. Now the last function what we need is to declare the result. Once your voting is complete, how you will declare the result, who is the winner, right? So in next lecture we are going to create a function which will be used to declare the winner. Finally, we need a function to declare the winner with the number of votes received. Let's write a function and we can give the name as result public so that anybody can call this function. And then what we will do is, since we already recorded all candidates and votes in vote received mapping, we can loop in the mapping and we will find the maximum number of votes. Once we find the maximum number of votes, we can return the candidate's address and the number of received vote. So how we can do it? We will have a for loop and this for loop will be executing till number of candidates minus 1. So we can write as I is less than candidate list dot length and then I plus plus. Now if you remember, we have two variables here. We defined winner and winner votes. So the default value of this winner votes is 0. So what we will do is, we will have a if condition and we will have our vote received mapping. Within this vote received, we will pass the address of the candidate like this. candidate list I. So what we are doing is we are passing the address of candidate at index I to the mapping table. That means we want to know the value of that address from this mapping, and the key is the address we are getting from this candidate list at index I. So candidate list index I is giving you address, which is the key for this mapping, and this expression will actually return you number of votes, and we can put like if it is greater than winner votes, then we can write winner votes equal to the same thing, vote received this, and winner equal to this candidate list I. So what is happening here is we have this winner votes defined as a state variable. Initially it has the value of 0. So when I equal to 0, the candidate list I will return the first candidate address, will go to mapping with that address, and mapping will have the number of votes received by that candidate, and we will compare if that is greater than 0. If it is greater than 0, we will save that vote in this winner votes, and we will also save that candidate address in this winner state variable. Second time when I equal to 1, this mapping will give the number of votes received by candidate second. Again we will check if the candidate second votes is greater than winner votes, and this time winner votes has the value of candidate 1. So if candidate 2 is greater than candidate 1, the number of votes received by candidate 2 is greater than number of votes received by candidate 1, we will override the votes of candidate 1 which is saved in winner votes by the second. If not, then it will go to I equal to 2, and winner votes will still have the number of votes received by candidate 1 when I was 0. So this logic will actually give you the entry of maximum number of votes. Let's deploy it and run this contract. So we have the first account selected as a contract owner. We will deploy it. So our contract owner is CA35B. Now let's register few candidates. I will select the second address, copy it, make it contract owner again, paste it here in register candidates, click on this, first candidate registered, copy the third address, change the contract owner, click on register candidates, the second candidate is registered, and then copy this fourth address, it will be our candidate third. Click on register candidate. So if you go to candidate list, 0 has first candidate 147, second candidate is 4B0, third candidate is 583. Now suppose somebody is voting. Let's select any account. So we selected 0xDD8. It is considered as a voter, and this voter wants to vote 0x58303. So he will pass this address, click on vote. You can click multiple times just to test, like this candidate has a few vote. Now let's select any other candidate. Second candidate is this one, 0x4B. Copy this, paste it here in vote function, and again click few more times. So this candidate is receiving some votes. And what is our first candidate? First candidate is 0x147. Let's copy it, paste it here, and again give one couple of votes. So if you just copy this address, the candidate address, and go to vote received, it will give you how many votes it has received. So 0x147 has received 2. That is the first candidate. The second candidate has received 9. And third candidate, which is 0x58303, has received 4. So 294. So definitely the second candidate is the winner. But what we will do, we will click on our result function, and it should return us the second candidate address. So this function is executed. If you click on this winner, these are the state variables. That just to show you the result, I have declared these as a public. Otherwise you can have returns, and you can return the address here as well. Click on the winner. This is your second address. If you just copy it and paste it here in vote received, see, it has the 9 votes. This is our candidate second who has received the maximum number of votes. So this is the winner, and if you click on the winner votes, it will return you 9. This is how you can create your voting smart contract, where you can have your register candidate function. So a owner can register the candidates, then anyone can call this vote function to vote the favorite candidate. Then you have validate candidate function, and then we have a vote count. So anyone can call this function, pass the candidate address, and get to know how many votes have been received by that candidate. And Finally, we have a result. This is a basic smart contract, but our smart contract, this vote function, should only be functional when the voting is in progress, right? When winner is declared, then if somebody will call it, it should not work. Again, the same thing with this vote count. This will return vote when the voting is in progress. Once the voting is done, only this winner function should give you the result. So how we can do it? In next lecture, we will see how we can implement logic for this. Now everything is working fine, but we need few more checks. Like result function should only return the winner if the voting is completed. Voting count function should only return counts if voting is in progress. Vote function should only allow voters to vote if voting is in progress. So to implement this logic, these checks, enums is a great solution for this. So we can define enum as enum. We can give the name like voting status, and within this parenthesis we can give all the status what we want. So let's give not started, then we can give running, and then we can give completed. So once we define this enum, we have this enum data type voting status. So we have to define a variable. So this is a data type now for us. So this is a voting status public, and we can define a variable called status. So if you have any question on this, or if you have any confusion on this, I would recommend go and revisit the enums lecture. So once we define these status, right, we need to set the status. So then we need a function which should be only called by a contract owner to set the status of the voting, and using these enums. So write a function. We can give the name set status. It should be only executed by only owner. So we have modifier, then can add public, and inside this we can check if status is not equal to voting status, that's a enum data type, and we have the value completed. Then we can set status equal to voting status dot running, else status equal to voting status dot completed. So what we are doing here is, when the contract owner can set the status of the voting process. So by default, this voting status will have this value, not started. So what owner will do is, it will check if voting status is not completed, then owner can actually set the value as running, and running means voting is in progress. And when contract owner wants to end the election or the voting process, he can call this function again, and that time the control will go to the else condition, because in our functions we will set this status value to voting dot completed. So let's see how it will work. So once you will see the example, you will understand this logic. So let's start from the vote function. So vote function we want only functional when the voting is in progress. So what we can do is, we can have another require statement. You can also use assert, but with assert you cannot have this error message. Just for learning purpose, I want to show you the error message. That's why I'm using require. Otherwise I can use assert. So require, and here we can check status equal to voting status dot running, and we can give the error message election or voting is not. That means when somebody will call this vote function, okay, first check will be the validation of the candidate, and the second statement is require status equal to voting status dot running. That means it's checking if the voting is in progress or not. So running means the voting is in progress. If status is running, then only it will go and vote. You can have this require as a first statement and the first one as a second statement. So we can copy this and implement similar logic in other function. We don't need this in validate candidate, because validate candidate will be called by vote. So we will need like vote counts. Vote counts should be only functional when the voting is in progress. So same thing we can just write here. Now as I said, you can use assert as well. So assert, you can use assert, and then you can just remove this message. So our vote function will execute these lines, vote received candidate +1 only if that voting is in progress. Vote count will do the same thing. If voting is in progress, only it will return the number of votes received respective candidate. Now this result, this should only give you the winner result if the voting is completed, right? So we will write here, before for loop, you can write this. Sorry, I copied the wrong statement. You have to copy this required status, just copy it, and you can actually paste it here. and this should be only executing when the voting is completed. So write completed, and the error message should be like voting is not, and you can write result can't be declared, something like that. So when this result function will be called, the status will be checked. If status is completed, only then it will go and find the winner and the number of votes received by that winner. Otherwise it will, if the status is not completed, then it will give this error message. Now we have a contract ready. Let's deploy it. We can have first address selected as contract owner address. Let's click on deploy button, and you can see the contract owner address starts from 0xCA35B. Now we can register few candidates. So copy the second, third and fourth address as our candidate first, candidate second and candidate third. And make sure you are calling the registered function using the contract owner address. Second address, it will be our second candidate. Then we have 0x58, it will be our third candidate. We can verify it from candidate list. At 0 we have a one candidate 0x147, second candidate is 0x4b0, third candidate is 0x583. Now so this function is working. So let's copy one of the candidate address and paste it and pass it in vote function. And if I go and click this vote function, that means I want to vote this candidate, but owner has not set up the status yet. So if you see the status, it's 0. 0 means the enum's first value, that's like not started. And this vote function should only be functional, or it will accept the vote if the voting status is running. And if I am not trying to vote now, it should fail. It should not add vote in mapping table. So if I click on this vote, it's giving you the error election is not active because our status is not started and this required condition is working. So what we will do is, as a owner will actually set this address. So we have the owner as an account here. Now if we click on this set status function, if you check the status value is 1, and 1 means the second in enum. This is 0, this is 1, this is 2. Now if you call this vote function, it will run fine. If you call 2-3 times, and if you check your vote, you will see 3 votes. Let's give some votes to other candidates as well. So I will have this candidate 1. Let's paste it with the vote function. Click few times. Let's get the second candidate. Paste with the vote and click few more times. And if you have the same address in vote counts, it will show you we have given 5 votes. Now, so this time the status is 1. That means the vote is running. Now if you click on this result, it will give you error. Voting is not completed. Result can't be declared. Because with this result function, we have this status. We have this required statement, right? So it will only give you the winner and the number of votes received by winner if the status of the voting is completed. So owner will go and set the status as completed. So owner can actually call this set status function. And now if you check the status, it's 2. 2 means completed. This is 0, 1 and 2. Now if you click on this winner list, anyone can call this winner function. So let's change to any other address. And if you click on this result function, it executed successfully. If you click on this winner address is 0x4b, and if you click on the winner votes, the vote number of votes received by this address, this candidate, 7. So hope you understood how you can develop the voting smart contract. The idea behind this contract is, this is one of the best use cases of decentralized application. If you write this smart contract, you will revise many important features of Solidity, like how you will use the address, how you will use the dynamic array, how you will use mappings, then enums, constructor, modifiers, how you can set or reset your enums status, and then how you can apply the error handling, how you can use require, assert. These all things you will revise in this contract, and also the loops, the control statement. So hope you enjoyed developing this contract. That's all in this section. Thank you.